welcome to the continuation of our discussion on primes and greatest common divisors. The last time you would have seen this material would have been before the campus closed down due to the coronavirus lockdown we're having here in the Bay Area. So please take a moment and pause the video if you need to, and just review these notes. If you don't have them written down, now would be a great time to write them down. All right, that said, let's continue. So let's find the prime factorization of 2020, our year that we're in. Actually, we are in the year 2020. So this number is clearly an even number. So we know 2020 is equal to 2 times 1010. Now 1010 is divisible by 10. So we get 2 times 10 times 101. 10 is clearly 2 times 5. So now we just have to figure out if 101 is divisible by anything. So for that, let's use the theorem from the previous page. Well, the square root of 101 is approximately 10. So it's going to be a little bit more than 10. So it's close enough to 10. Let's just say it's 10, about. And the primes less than 10 are 2, 3, 5, and 7. So 2 does not divide 101, since 101 is not an even number. Three does not divide 101, and this we covered when we were in class before the shutdown, because the digits of 101 do not add to something that is divisible by 3. Next, 5 does not divide 101, and that's visible because the last digit here is not a 0 or a 5. And finally, what about 7? Well, for a number that's like 3 digits or less, it's fairly easy to just divide by 7. So let's try that using some long division. 7 into 101. 7 goes into 10 one time. We're left with a difference of 3 there. And 7 goes into 31 4 times. That gives us 28. And notice we have a remainder of 3. So 7 does not divide 101. I did post a link to a separate video about some properties of divisibility by 7 that we did not discuss in class. Okay, so the prime factorization then of 2020 is 2 squared times 5 times 101.